pick up from yesterday, just want to remember, first of all, what we're doing is working with two different forms because they both give us information. This format gives us x-intercepts, and the standard form gives us the y-intercept. And there's going to be some more stuff it gives us later once we learn that part. But just remember, just to follow all the steps, don't take any shortcuts. It's going to be tempting. You're going to see like, oh, I could just do it this way and I get the answer without much writing. As soon as you start taking shortcuts, I guarantee the harder problems are going to get very confusing. So resist the temptation and just show everything and you'll stay safe. But every year we got some people saying, I'll just do it this way. It's the same. If you're only thinking about the answer, that's the problem. Okay? There's more to it. Okay? Don't forget distributive property. That's when you just multiply in. So we got 8b minus 56. Now, what does factoring mean? When it says factor, what does that mean? That's the reverse of distributive property. So what we just did on 13, how we multiplied the same number in, factoring is taking the same number out, divided out. So what number can you take out of 42 and 54? What number goes into both? 6, right? Or 7? Which one? 6. 6 is the number that goes into both. So what's left over? Well, if you divide 42 by 6, you get 7. And to the 5th, if you divide 54 by 6, you end up with minus 9. So it's just the reverse of distributive property. It has to be the same number, just like we only distribute 8 in. Right? We can't say like, oh, well, 6 comes out of this, but 9 comes out of 50. You know, you have to do the same exact number. So just think of it in reverse. Okay. One more time. If there is a negative in the front, that's automatically taking out a negative number. So what number comes out of 72 and 32? 8. But since it's a negative in front, take out a negative 8. Okay, just a standing rule because when we're doing the factoring and x-intercepts, it's much easier if what's left inside here is a positive to start off with. So if we take out a negative 8, we'll have positive 9n. And that's what you want to go for, have a positive 9n. So this would have to be a plus 4. Because negative 8 times 4 is negative 32. So that's called factoring. A GCF technically agrees it's called factoring. But think of it as just the reverse of distributive property. Okay, so where we left off yesterday is that if you look at everything we did yesterday on the front here, you notice how it always started with just something squared. N squared, b squared, p squared. There is no number here other than 1 p squared, right? And now we get down here, the difference is that there is a number. Okay? So if you saw the shortcuts yesterday, you probably picked up on, I probably don't need to write all that work. All this work that you're doing, you probably didn't really need to do it. You just figured out, oh, it's negative 2 and negative 1. You can just go straight to the answer, negative 2 and 1, and you'll get your answer, right? If you caught on to that. But, 8, 3, 8, 3, right? You probably catch on to those answers. Well, I don't really need to do all this because I can just go from the x and go straight here. I didn't want to show you that. I didn't want to tell you that because that's only true when there is no number. But most of the trinomials you're going to be factoring do have some number here, and you cannot just say, well, 1 plus 12 and that's 12. It does not work. You do have to show a lot more. Everything that I was showing you yesterday, you have to do that. So let's try it. I'll show you what adjustment we're going to make. Okay. Recall that this is the a value because it's in front of the squared term. This is the b value, and this is the c value. Now, yesterday you were putting the last number, the c, on the top, and the b value on the bottom. But when you have something other than 1 here, for a, you have to put a times c on top. So what we're going to do is we're actually going to multiply these two together, 7 times 12, and get 84. B, still B. That's 20. So that's the difference when you have a number in front. It's actually these two multiplied, the A and the C. And so we don't want to take any shortcuts. If you didn't do it last night, you know what I'm talking about, you're in good shape. If you did try to get too fast and too easy and make it too simple, stop doing that. Make sure you start showing all the work that you have to do. Right, now you notice the numbers are a little bit bigger. That's going to be a little bit harder. Some people like saying this is the attic. It's on top. Some people like saying this is the basement, so the attic basement. Basement is always on the bottom. I know we don't have basements down here in our house. Another way of looking at it. Remember the attic, that's where we multiply. And the basement is where you're at. So what two numbers multiply 84 and add 20? You might have to think about it. You might have to do a lot of trial and error. Once again, a calculator is very handy. So if you still don't have a standalone calculator, it does help you when you're trying to do this trial and error. You really just have to go through a few of them. Very few people are going to look at this and say, oh, it's these two numbers. You're going to have to try some numbers. Oh, that doesn't work. Try some other numbers. That doesn't work. So give yourself a second. See if you can figure out what two numbers multiply to 84 and add to 20. So you probably tried things like maybe 16 and 4, right? That adds a 20. Does that multiply to 84? And like, no, that's only 64. You might have tried what adds a 20, maybe 10 times 10, but that's 100. So that doesn't work. So you have to go through maybe several different trial and errors until you find the right numbers that work, which eventually were 14 and 6, right? Those equal 84, and you multiply, and 14 plus 6 equals 20. So it's not going to be something that's automatic and super easy all the time. Sometimes they're easier than others. So let's finish it up. So what I'm doing, same thing as yesterday. I'm going to replace my 20b with 14b plus 6b. Okay? But everything else stays the same. So I got 7b squared in front, the plus 12 on the end, right? And I'm going to go through the same steps I did before. So what can we take out of the first two? What do these both have in common? All right. What do these have in common, Kenny? And what else? And what is the number? Good. Okay. So what's left over inside? Well, if you take a 7 and a b away from this, if you take a 7 away from 14, you have 2. Because remember, this has to multiply back to equal this. So you're thinking backwards from distributive property. Now remember, this second parenthesis I get over here has to match this one. So that's a helpful tool. So what comes out of 6b and 12? What can you factor out? They both have a 6, right? 6 is the biggest number. What's left over? B plus 2. So if you took out any other number, because 3 comes out of both of these, 2 comes out of both of these, you'll notice that these don't match at the end, so you know something's wrong. These must match at the end, otherwise you didn't take out the right number. So there's a little check built into these as you're going along. Okay? And of course the leftover one right here is the other one. 7b plus 6. Now you see why you cannot just take these two numbers and just put them in parentheses, right? We got 14 and 6. It's not 14 and 6 in here, it's 2 and 6. And that's why you can't take that shortcut of what some of you might have been doing over here, right? You might have been just saying, oh, I got 8 and 3, I just write 8 and 3 and I'm done. It doesn't quite work anymore. So anytime you have a number that for that A value that's something bigger than 1, something other than 1, then you do have to show all the steps. Okay, let's look at 20. I'm going to do the other method, the box method. So let me set that up and let you guys finish those up. So draw the box. We still have the same setup as we did yesterday. I want the 2n squared here. I want the c on the end. That's our y-intercept, by the way. Don't forget that's the y-intercept when we graph. But the 17 I need to break up into two parts. So I'm going to have, what goes on top here, by the way? What goes in the top? A times c, which is 16. In the bottom, the basement is 17. So what multiplies to 16 and adds to 17? 16 and 1. So we got 16n plus 1n. And now we can do the rest of it. So what comes out of 2n squared and 16n? What do they have in common? So for the number, they both have 2. They both have a 2. 2 comes out of 2. 2 comes out of 16. But they both have an n as well. So we take an n out as well. We have to take everything out that's possible. Can't just leave the n in there and just take out the 2 only. And then you can work backwards. So 2n times what is 2n squared? Let's get n. And n times what is n? Right? That's what this means. N times what equals n? Is 1, right? 1 times what is 8? And you get 8. 8 is also the GCF, or what you can factor out as 16 and 8. It's the same thing. So you can do this several ways. And then there's your answer. Doesn't matter on the order, 2n plus 1 and n plus 8. By the way, you can always do a check, multiply and back together. See if you get what you started with. 2n squared, 16n, because we're just doing this backwards, plus n, plus 8, which equals 2n squared plus 17n plus 8. That's what we started with. So if you multiply your answer and you get what the original question is, you know you did it right. So nice thing about these is when you're turning in your quizzes and your tests, you can do a check on every single problem and know if you got 100%. You should know your grade before you turn it in because it's so quick, about 5 seconds, and you can check every problem. So even if there's 20 problems on the test, that's like 2 minutes, 3 minutes of work, and you know what your grade is before you turn it in. Okay? So ask yourself, are you willing to do that? 5 seconds per problem, know what your grade is. Or are you just going to finish it and say, oh, I'm done, and turn it in? Okay? That's the difference between sometimes a C and an A, or an A and A+. Some people say, I'm not good at math, I don't know how to do it, and it's just harder. Other people can do it really fast in their head. That's why they're good at it. Or maybe they spend 3 more minutes checking their answers and they get a higher grade than you. I think the latter sounds a little more reasonable than just magic, they're good at it. They just spend 3 more minutes, which goes by so fast you think they just get it faster automatically. Really, they're using those 3 minutes to check every answer. That's why they have a higher grade. No other reason, no magic math thing, or I'm just a good math person, I'm a bad math person. Spend 5 seconds per problem doing a check. Now you have a higher grade. Okay, no magic involved. Just, checking to see if your answer is right. That's all it is. So go ahead and try the next few. Use either method or use one of each and see how you like it, and then we'll go over it. Okay, so the last one, what were the two numbers that worked here? Just 10 and 6. So we got 10r plus 6r plus 20. From here, you can only take out an r, right? Because 3 and 10 don't have anything in common. So we can only take out an r, so we just have 3r plus 10. From the second one, we can take out a 2. So we take out a 2, and we have 3r plus 10. Remember, those have to match inside the parentheses. So there's one answer, and here's the other. Okay? All right, finish up the rest and of the homework from last night on the back, and then we'll start tomorrow with Khan Academy again.